Now we'll see some problem based on Planck quantum theory. So Planck quantum theory tells that the energy released from any particle is equal to h into frequency. So if number of particles also there, so it also depends on the total number of particle into h into nu. So that is the Planck quantum theory. So based on this, so we will solve all problems over here. So a certain laser transition emits this much quanta per second per meter square. So calculate the power output in joule per square meter per second. Lambda is given here. So this is the total energies. We have to calculate the power per second. So we will divide by this much. We will get here power per second. So here power output will be how much? This will be your total number of quanta multiplied by hc upon lambda. So hc upon lambda, this is nothing but the h into c upon lambda. So this is the value. So we will put here value. So h is 6 point hc. So this is the number of quanta is 6.37. This is total number of quanta. This much quanta released per second. So this is your, and h is 6.34 into 10 to the power minus 34 multiplied by, and this is the wavelength of, this is the speed of the light, divided by 8 and divide by total number of wavelength of the light, that is 632.8 into 10 power minus 9. So we will get answer. If you solve it, you will get answer 2 into minus 3 joule per meter square per second. So this is our answer. So this is the power output in joule per square meter per second. Now second questions. So the dissociation energy of hydrogen is 430 kilojoule per mole. If hydrogen is exposed to radiation, energy of wavelength 253.7 millinanometer, what percentage of radiant energy will be converted into kinetic energy? So we can see here. So percentage we have to write it in converted. So we can write here. So energy of the HH bond. So energy of HH bond is 453.53 kilojoule per mole. This we can write 430.53 into 10 to the power 3. So per mole means 6 into 10 power 23. So we will get here joule per molecule. So this much energy we are getting. So this is something 7.15 into 10 power minus 19 joule. Now how much we are giving total energy? So total energy we are providing, total energy provided is equal to hc upon 253. So this is the our wavelength in 10 power minus 9. So this is the wavelength, right? This is total energy we are providing. hc I am not writing. So if you calculate the value of h and c, so you will get here 7.83 into 10 power minus 19 joule. So this is the total energy we are providing. Now this is the for one to breaking the one hydrogen. This is the energy of the hydrogen molecule. Okay, so per molecule is given here. This is the per mole. This is the per molecule. Per mole, this energy, and total energy we are providing. So now, if you give this energy to this much, so how much energy left? So energy left after dissociation of HH with hydrogen molecule. So how much energy left? So 7.83 minus 7.15. So multiply by 10 per minus 19. So this much energy left, which is nothing but 0.68 into 10 per minus 19 joule. So percentage of energy used into kinetic energy is very simple. The total energy we know that is 0.68 into 10 power minus 19 and divide by total energy is 7.83 into 10 power minus 19 into 100. So this percentage, it will come 8.68%. This is the answer. So now iodine, a molecule dissociates into atoms. Iodine molecule dissociates into the atoms after absorbing light of wavelength 4500 angstrom. So if one quantum of radiation is absorbed by each molecule, so calculate the kinetic energy of the iodine atoms. So bond energy of iodine is also given 240 kilojoule per mole. Okay, so we can write here. So energy, first total energy is absorbed by the light is 4500. So this is the total energy, and one quantum energy absorbed by the each molecule. So we have to find the one quantum of energy. So energy used to break the iodine molecule. So first we write energy given to iodine molecule, how much, minus energy used to break iodine molecule. Okay, and this will give you energy used to split two iodine atoms. Okay, so you have to recall the iodine atoms. So total energy given by is Hc upon 45 it is 100. So this angstrom minus 240 into 10 power 3 divided by Avogadro number. So if you solve it, so this will come 4.417 into 10 to the power minus 19 minus 3.984 into 10 to the power minus 19. So this was something energy will come. So this is nothing, this is equal to 0.219 into 10 to the power minus 19 joule. So this is the total energy utilized to break the two iodine atoms. Now see, a bulb emits a light of 4500 angstrom. The bulb is rated as 150. So watt, and 8% of energy emitted is light. How many photons are emitted by the bulb per second? So again same. So E equal to N into H nu, or this we can write E equal to Sc by lambda. Lambda is given here. This is nothing but the energy emitted by bulb. So we can put value. So N into, so we can write here. So Hc, H nu, if you solve it, so lambda is given already, that is 4500 angstrom. So Hc by 4500 angstrom minus 10. If you solve it, energy given by the bulb, so it is totally 150 watts. So we can write here 150 into 8%. This is our 8%. If you solve it, this is nothing but it will come 4.42 into 10 power minus 19, and if you solve it, 150 into 8 by 100. So on getting N equal to 2.72 into 10 to the power 18. So this much photons are emitted by the bulb per second. So calculate the number of photons emitted in 10 hours by a 60 watt sodium bulb. So lambda photons is given this much. So again very simple. So energy of photon, so this will be equal to Hc, and lambda is given here 5893 into 10 power minus 10 angstrom. So this will become what, 3.37 into 10 power minus 19 joule. So number of photon emitted out in 10 hours. So we can have to emit in 10 hours. This will becomes 10 again. So energy is how much emitted. So we have seen here. So this is 3 by 3 into 10 power minus 9. This is the total energy, and again this is per hour given. So per hour you have to convert into per second. So because this is the watt, we are getting how many photons emitted 10 hours by this one. This is 10 hours and this is in seconds. So we have to convert into this one hours. Total watt is given 60 watt. 60 watt to 10. This is there. Now convert into seconds. So this will be your 30. This will equal to, this is watt hours. This we have to convert to second also. So 10 hours means 10 into 3600 seconds into 60 and divide by 3.3 into 10 to the power minus 19. So if you solve it, you will get here 6.4 into 10 power 24. So this much number of photons is emitted in 10 hours. Now suppose 10 power minus 17 joule of light is needed by the interior of the human eye to see an object, and how many photons of green light are needed to generate this minimum amount of energy. So this much energy will be required by the human eye, and so how many photons of green light means we are getting light energy of this much light. Okay, so out of this much light, so this much light is providing and this much light is given. Okay, so suppose this much energy needed and this much is given. So how much this much needed to, how much photons of green light are needed to generate this minimum amount of energy. So what is the number of photons? So first we have to find out here. So what is the total number of energy per photon? So energy of photon will be how much? So wavelength is given here. So hc divided by 550 into 10 power minus 9. So this is the energy of one photon. So if you solve it, this will come about 3.61 into 10 power minus 90 joule. This is the energy of one photon. So total energy, total photons, how much required? We are supplying 10 power minus 17. So number of photons required is, total energy we are giving minus 17, and per photon is 3.61 into 10 power minus 19 given by green light. Your number of photons will be 27.7 photon, or roughly we can say n equal to 28, because 27% is the figures. So we have to complete it in this much round figures. A photon of 300 nanometer is absorbed by a gas and re-emits into a photons. Okay, so for re-emitted photons have wavelength 496 nanometer. So calculate the energy of the other photons re-emitted out. So again same, so we can write here energy absorbed. Okay, so energy absorbed will be equal to here hc by, so wavelength is given by minus 9. Again next hc by 4.96 into 10 power 9. So this energy is what? Energy of the first photon, and this energy is the energy of second photon emitted out. Second photon emitted out. No, we have to find the other photon emitted out. This is the, so energy absorbed is actually this, you write here, not just to make proper, draw it. Energy absorbed is equal to energy of first photon plus energy of second photon emitted out. So the first photon is hc by 300 into 10 power minus 19 minus 9, and this is the energy of second photon. So energy of second photon will be equal to total photon is hc by 300 into 10 power minus 9, and minus, so absorb is how much? So hc by, it is given here, the same, it has been absorbed. So this is 496 into 10 power minus 9. So on solving, so we will get here 6.625 minus 4. So you will get here 2.625 into 10 power minus 19 joules. So this much energy is emitted by the other photon. So during photosynthesis in the green plant were found that 10 quanta of red light, this much is needed to release 1 molecule of oxygen. So to release 1 molecule of oxygen, we require 10 quanta of this much energy. So average energy stored in the process is 112 kilocalorie per oxygen evolved. So when oxygen evolved, this much energy is actually stored, and this much energy is given to the molecules. So what is the energy conversion efficiency in this? So for 10 quantum energy, what is the total energy? So let us find out. So energy of 10 quanta. Okay, so this will be your 10 into hc by lambda. So lambda we know that 10 equal to hc, and lambda is 6850 into 10 power minus 10. The total energy will be 10 into 2.9 to 10 power minus 19 joule. And energy, so energy means average energy stored. Average energy stored is how much? So this will be 112 into 10 power 3, and calorie is 4.18, and per mole means per molecule will be 20 by 23. So this much energy is stored by the molecule, 7.8 into 10 power minus 19 joule. Okay, so this much energy is stored, and this much energy is so we require. Okay, so total energy how much? So total energy will be, we can see here. So on solving we can see, so percentage efficiency will be, so this is 7.8 into 10 power minus 19, and if you divide it here, so 2.8 into 10, this will becomes here 29 into 10 power 19, and again multiplied by 100. So if you solve it, you will get here 26.9%. So this will cancel. So again on solving, this will become 29. On solving 0.29, the 0.29 divide, you will get this much percent. This much efficiency is conversion efficiency of this. If you give this much energy, and if you try this much, the conversion energy will be 26.9%.